All right, so welcome to part 2, and we'll be doing questions 11 through 20 in this one. Okay, so let's start with question 11. You invest $16.20 in an account paying an interest of 3% for 15 years compounded annually. Calculate the accumulated balance at the end of 15 years. So let's go ahead and start this problem, and we're going to, because we're compounding annually, we can already kind of assume and jump to the equation that we have. Our amount is equal to the principal times 1 plus the rate divided by 1, because we're compounding once a year, times 1 times the number of years. So now we can actually kind of accumulate this down and just say, okay, that's just P times 1 plus the rate raised the number of years. Or you could do APR instead of R. I just kind of simplify that. So here we go, let's plug in our value. So it's 1620 times 1 plus the rate, which in this case is 0.03 or 3%. We're going to do that for 15 years. So we'll come down to our calculator, 1.03 raised to the power of 15 years. And then we're going to take this value and multiply that by 1620. And we'll get our value of 2523. 91, so A is the correct answer. All right, so let's move on to question 12. You invest $10,000 in an account paying 4% for 10 years compounded annually. Calculate the interest. So we can actually just use the same formula. So we'll come over here. That was problem 11 that I just did. So question 12, we'll use the same formula. P times 1 plus R to the Y. So our P is 10,000 in this case. 1 and 4%, so 1 plus 0.04. We're doing this for 10 years, so we'll raise it to the 10. So we'll clear out our calculator, 1.04 raised to the power of 10 gives us 1.48, multiply that by 10,000. And we get 14,802. Okay, now remember we're calculating the interest, so it's important to look at that value. And what we're going to do is, looking at those values, this is the actual count. 10,000 is what we started with, so 4,802 would be the amount of interest that we have. So I'm going to circle that. And this one, we can just subtract the principal, and that will give us the amount of interest we have. So that's how we chose that. Okay, number 13. You invest $2,000 in an account paying 3% for 2 years compounded monthly. Calculate the cumulative balance at the end of 2 years. So we're looking for the amount after this, and we're going to say P times 1 plus R over N raised to NT. Now, you'll sometimes see me use T instead of Y, or sometimes R instead of APR, and that's the same thing. It's just T represents time in years, Y represents years. It's just another variable just to represent the same thing to get the equation. So in this case, we have a principal of $2,000, 1 plus the rate, which in this case is 3%, divided by the number of times we're compounding. In this case, we're compounding monthly, so the number would be 12, and then 12 times the number of years, which in this case is 2. So we have 2,000 times 1 plus 0.03 divided by 12. I'll just calculate that real quickly. 0.03 divided by 12 will give me 0.0025. And this will be raised to the power of 24, because 2 times 12 is 24. So we'll raise this value of 1. We'll add 1 to this one so we get the correct value. And then we'll raise 24 to the power of that. So therefore 1.0617 is our value in here, and we'll multiply that by $2,000. Oops, we'll clear that and try it again. And 2123, since we're looking for the cumulative balance, therefore C is the correct answer. So we're looking for the cumulative balance. All right, let's move on to question 14. You invest $4,000 in an account paying 3% for 3 years compounded quarterly. Calculate the interest. Now, if you want to, I'm going to show you another way to do this. I could do what I did previously and then subtract the principal when I'm done, or I could just say, okay, you know what, this is just going to be the interest, so I don't, actually, let's just go ahead and keep it this way. It just makes a little bit more sense, and I'm not going to confuse it with another strategy. So P times 1 plus R divided by N raised to NT, and in this case, our principal value for 14 is $400. 1 plus the rate, and the rate in this case is 0.03. Compounded quarterly, well, that means 4 times a year. And we'll raise it to the power of 4 times the number of years, which in this case is 3 years. So I'll put 4 times 3. So let's go ahead and use the calculator at this point. 0.03 divided by 4 is 0.0075. We'll add a 1 to it. So that's the value in the parentheses. We'll raise it to the power of 12, because that's 4 times 3. And so we get 400 times 1.0938. So I'm just going to keep that in the calculator and multiply that by 400 so I keep it as accurate as possible. $437.52. Now what we'll do is we want to subtract, to find the interest, we're going to take that value and subtract 400 from it. So if I subtract 400, which was the principal amount, my answer is there's $37.52 of interest. So $37.52 is right here, and we're ready to move on to 15. So let's go ahead and clear out the page and start. So we invest $7,000 into an account paying interest of 3.6% for 5 years, compounded continuously. So we want to calculate the cumulative balance at the end of 5 years. Okay, so we're looking for the cumulative balance. So we're going to want the whole thing, not just the interest. So we have to remember the formula. And since we're compounding continuously, and we're on question 15, compounding continuously, we need to remember what that formula is, which happens to be the principal times e to the rate t. Okay, or if you look at your formula, that would be APR and y. Okay, and that would give you the same exact value. So this is just the way I learned it, so that's why I kind of stuck with that. But you could put APR here, and it represents the same thing, the rate, and then t represents the amount of time. And so e is actually a number. Let me just show you. So if I come over here and go e to the, let me refresh that, 1, and then push e. So what I just did is e to the power of 1, which is itself. E actually happens to be a number. It's 2.7182818284590, and it's like pi. It'll go on forever, so just keep that in mind. It's a representation of an actual number. So what we're going to do is we're going to get the RT in here and then just push the E button to get that value. So just to give you fresh memory on that. So let's go ahead and put in our formula. Principal is 7,000. E, now remember that's a number, 2.78. 718. R, which in this case is 3.6, so 0.036 times t, the number of years, which is 5 years in this case, so we'll multiply that by 5. So we'll come over here and do that value, 0.036 times 5, so it's 0.18, so e raised to the value of 0.18. And we'll come over here and go ahead and do that. So I'm just going to, on this calculator, I'm going to put 0.18 and then push E. So that's the value right there. So 1.1972. Then we'll multiply that by $7,000. And so we have $8,380.52 is our answer. So I could write that out, or I could look just up here and right there. D is the one that is correct, matches my calculator. All right, let's move on to question 16. Suppose you want to receive a college fund for your child. You would like to make a single lump sum investment now that would achieve a future value of $20,000 in 18 years, which your child then goes to college. How much principal would you need to invest in order to count on an APR of 5% compounding continuously? So let's start with what we know. We do know that we're going to probably use the formula for compounding continuously, since that's what they refer to. Okay. Now let's look at what we're given and what we're trying to find. Now we're looking for the future value, so that's the actual A. So I'm going to put in 20,000 into there. So that's our future value, what we're looking for. We don't know what the principal is. That's what, you notice that we can come over here and look. That's what we're looking for. How much principal. So when I find the principal, P, I'll have my answer. So hopefully I have everything else. If I don't, then there's no way to really find this. So that's what you use with equations. E, remember that's a number. R represents the rate. We want 5%. So I'm going to put 0.05 times, and then we want the number of years, in this case 18 years when your child goes to college. So notice I have everything in here but P. So now we're going to solve for P. So let's first calculate this. We go 0.05, oops, let me redo that, 0.05 times 18 years. So that's 0.9, and then we'll raise e to the power of 0.9, which gives us this value. Now I could, remember, we're going to multiply this by P to get to there, so I can actually divide it from 20,000 to get to P. So if I was to get P by itself, remember I could divide by this value. E to the, well actually we can say it's about 2.45, roughly. Now I could type that in, but once again I could get round off error. So what I'm going to do is I'm going to store this in my memory. Okay, so I stored that in memory. Now that I've done that, I can clear this out and go 20,000. And we'll divide that by the memory recall, which was that 2.45, which has all the value, and then $8,131 is my P. So that's how much I should start with, so that 5% compounded continuously over 18 years would give me a future value of $20,000. So we'll come up here, and B is the answer. So I'll circle that, and we'll move on to the next question, number 17. All right. A bank offers an APR of 4.5 compounded semi-annually. Find the annual percentage rate, the APY. Okay, so we're looking for the APY. So because we're looking for that, we want to have, remember, APY is what? It's our absolute increase over our starting principal. Starting principal, absolute increase. Okay? Now, which of these values do we know? Our absolute increase, so let's see, we need to first calculate that. So we're going to say, oops, let's find that. So first we have to find out how much we have after this time period, okay? So it's 4.5 semi-annually, and really it could depend. Let's just use some random numbers, okay? So I'm going to choose $100, let's say, okay? And we'll do this over the rate, which is 0.045. And since we're compounding semi-annually, it's going to be a 2. And a 2. And just to make life easy, we'll just keep it at 1 year. Okay, but you could have actually done this with different values, and then as long as you keep those values throughout the rest of it, that would help you with that. So let's go ahead and find this out. And we get 0.045 divided by 2. Raised to the power of, we add 1 first, there we go. And then we'll raise it to the power of 2, and we get 1.0455. We'll multiply that by 100. And if I was to invest compounding semi-annually at 4.5, I would have $104.55. Okay? So now what we want to do is, remember, we want our our absolute increase, which is actually what we have here minus the principal. So 104.55 minus the principal, which in this case is 100. That's what we started with. And we'll divide it by our starting principal, which in this case was 100. So we'll subtract 100 and then divide by 100. So our APR is actually 4.55%. So we look up here, and A is actually the correct answer. And so once again, I could have actually put a different value in here instead of 100. I could put 200, 1,000. Okay, it really didn't matter, because then it would change out what I got here for an answer. It would change out what I got here and what I got here. Since we're looking for the APY, you always have to put a 1 in there. Okay, so those are just the few things to remember as you work on a question very similar to 17. Okay, let's move on to 18. You want to retire at the age of 65 and would like $100,000 in income each year forever. Assuming you can earn an average of 5% for an APR and only interest would be spent each year, how much money would you need to have invested in a lump sum in order to pay $100,000 per year in interest only? Okay. So what we want to do in this one is we want a future value. Our future value has to be 100,000, and we'll do it the principal times the rate. Okay. So what we're going to do is we want to solve for that principal. Okay, how much we put in at the one time, so that if we have an APR of 0.05, it will give us 100,000. And so notice that what this is doing is that's just like if I pull it out, okay, that interest I've received is all I'm looking for. So I can actually go 100,000 divided by 0.05 to give me what that principal should be. So it's a very simple 100,000 divided by 5. I'm sorry, 100,000 divided by 0.05. Sorry, 0.05. And we get 2 million. Okay, so B would be our answer in this case. All right, let's go ahead and scroll up. So we're going to do for number 19 right now. And it says, what if you wanted to become a millionaire and had 45 years to get ready for that goal? What lump sum could you invest to make that happen? Remember, we're looking for a future value of $1 million, assuming you averaged 7% compounded monthly on your financial portfolio. So A is equal to the principal times 1 plus the rate over N, all raised to the NT, or you could do an APR and Y. And you'll see that that's the formula you'll get on the formula sheet. So P, principal, is what we're looking for, because remember, we come over here, what lump sum could you invest? So what principal could you invest is what we're looking for. So we don't know the P. We do know the future value, $1 million. So I'll put that in right here. And we do know what the rate would be. We're going to assume 7%. And we're going to compound this monthly. So we'll put 12. Now, how much years do we have to do this? We have 45 years in which to do this. Now, once again, we're not making monthly payments. It's just one lump sum we're going to put down and then we'll get $1 million. That's really what we're looking for in this problem. So if I had this money sitting aside today and I put it in and I got 7% interest for 45 years, I would get $1 million. So let's do this calculation. 12, let's clear that out, make sure, 12 times 45 gives us 540. So I'll just keep that in mind. P times 1 plus, now we'll do 0.07 divided by 12. It's going to give us a long number. We'll add 1 to that. And we'll raise it to the power of 540. If you remember, that was our previous 12 times 45. So we get 23.1234689. Okay. And this was like 0.005, yada, yada. And that was 540 and 1 million. Okay, so what we're going to do is P times 23.12 yada, yada, yada is equal to $1 million. So in order to find P, we're going to have to divide both sides by that 23.12 dot, dot, dot. So I'm looking for 1 million divided by that value. So let's do first a memory clear. So we cleared the memory, and then we put a memory plus. So we're going to add that into the memory. We're going to clear this out, and I'm just going to do a memory recall to make sure I have that correct. Okay. Now I'm going to do 1 million. I'm going to divide it by the memory recall, which was that 23.12. And the reason I do that is so I can keep all of my accuracy as much as possible. And so 43,246 and 11 cents, roughly. Well, okay, so they're rounded to nearest dollar, and D happens to be that correct answer. All right, let's look at number 20. Last one for this problem. Carrie invests 682 in investment that earns 5.5 compounded annually. Andy invests 682 in investment that earns 7% compounded annually. How much money is in their accounts after 10 years and after 20 years? Okay, so we're going to have to do quite a few calculations, so we'll have to, but at least we're just going to stick with a very simple problem. We're compounding annually, so I don't have to worry about the ends over there because it'll divide by 1 and be multiplied by 1. So let's start with Carrie. And so Carrie will have the principal of 682 and earns 5.4 compounded annually. So we're going to go 0.054, and we're looking for 10 years. And we're also going to look for 20 years. So let's just go ahead and plug those in. So I clear everything out, and I'm going to do memory clear as well. Okay, so 1.054 raised to the power of 10, and then we're going to multiply that by the principal, which is 682. So after 10 years, she'll have 1153. So let's look. 1153, and actually because none of the other ones have 1153, you already know that C is the correct answer. Okay, let's assume that some of those had another one, so I'll just continue going on just to show that how you can do the rest of these. Let's do the second problem, 1.054 raised to the power of 20. So raised to the power of 20, and we get that value, and we multiply it by the principal, 682, and 1952. 1952, so yep, that confirms that. Let's quickly do Andy, and we'll be done with this part 2. 682, now remember he's investing at 7% and 10 years. 07 and 20 years. So I'll clear this out. And 1.07 raised to the power of 10 years, multiplied by the principal of 682. He has $1,341.60 after that, and we'll just verify the last one. 1.07 raised to the power of 20 years, multiply that by our principal of 682, and $2,639.12. Okay? All right, go ahead and for questions 21 and 30, just go on to part 3.